Hello friends, welcome to my home. Today we're going over the test, but this is the first test I gave you. We're going to be doing this page by page because there's a lot of problems and I don't want this video to be super long. Alright, we start off with the most fundamental problem that I really want everyone to get. What is the definition of the derivative of the function f of x? So, if we're going by definition, a derivative is just a limit as something goes to zero of a particular difference. Now there's a couple options here. The one you're going to see most often is limit as h goes to 0 x plus h minus f of x over h. This is the one that I've kind of tried my best to beat into you, and the one that I don't want anyone to forget because that's the one you're going to see most often. There are a couple other ones that you might see. For example, you might see it limit where instead of h, they say delta x to kind of represent what actually is going on. It's a difference going to 0. So x plus delta x minus f of x over delta x. You might there's another one that involves y, and again, if we're out to derivative, if they said at c, you might see it as a limit as x goes to c of f of x minus f of c over x minus c. All of these are good answers and true answers, and this is the one that I want you to remember the most. All right. Now let's get on to it. If y equals 3x plus 2 over x minus 3, what is dy dx? This is set up to make you think, and in fact it is a straightforward quotient rule problem. So quotient rule goes, if we have a u function divided by a v function, the derivative of that is the derivative of bottom. Sorry, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So we have x minus 3 times the derivative of the top, which is just 3, minus the top, 3x plus 2, times the derivative of the bottom, which is just 1, all over x minus 3 squared. And then I would like to advocate simplifying as much as you can. You get 3x minus 9 minus 3x minus 2 over x minus 3 squared. The 3x's cancel. You get negative 11 over x plus 3 squared. Try to simplify. It makes your life easier if you have to do something more with this. Okay, moving on. If f of x is equal to 2 over x squared minus 1 over x plus 3, then what is f prime at 2? So we're going to find our f prime by taking the derivative term by term. So f prime, the derivative of 2 over x squared, you can either use the quotient rule or the way I'm going to do it in my head is changing this into 2 times x to the negative second. And similarly, this would be minus 1 times x to the negative first. And let's take derivatives using the power rule. So this becomes negative 4 x to the negative third plus x to the negative second, and then derivative of 3 is just 0. Now when you plug in 2 here, you of course get negative 4 over, I'm going to actually switch back to this as a fraction, just that's how it's nicer for me. X to the, or 2 to the third is 8. And then we have plus 1 over 4. we get negative 1/2 plus 1/4 equals 1/4. And there we go. For what values of x is the graph of y equals 4 over x minus 3 concave upward? Now, I do not want you to use calculus for this. You can use calculus, and I'll show you how, but really, you should be able to solve this without any calculus by examining the function. So we see that this is just a simple reciprocal function, which has a vertical asymptote at x equals 3. And since the numerator is positive, this is positive, it must have this shape. From that shape, it is pretty easy to see we're looking for concave upward. Well, this is the region that's concave upward. Our answer should be x greater than 3. Now, how do we do it with calculus? Concave upward means that the second derivative is greater than 0. So we're going to have to take the derivative. So we look at this function, if y equals 4 over x minus 3, and change that to y equals 4 times x minus 3 to the negative first. Then use the power rule. That means that dy dx equals negative 4 times x minus 3 to the negative second. And it means that the second derivative of y in terms of x is equal to 8 times x minus 3 to the negative third. All right. If this is greater than 0, that means that certainly 8 is greater than 0. For this fraction to be greater than 0, just the x minus 3 part has to be positive. I'll switch back to positive, negative. For this multiplication to be positive, this is always positive, so this part has to be positive. Raising something to the negative third power keeps its sign, so that means x minus 3 has to be positive, or x is greater than 0. So obviously, the first method of knowing something about functions takes the least amount of work. This second method takes some amount of work. If you are using the quotient rule on this to take the derivative twice, that's going to take the most amount of work, and I recommend you don't do it. Of course, if that's all you can remember at the time, that's all you can remember, but there are other ways and there are better ways. Moving on. This was the hardest problem on the test, or designed to be the hardest problem on the test, because it required the most reasoning. For what values of k does a function y equals x cubed minus 3x squared plus k have 3 distinct real roots? Okay, so let's think about this for a second. If it has 3 distinct real roots, it has to intersect the x-axis 3 times. Since it's a cubic function, all cubic functions, especially cubic functions with a positive leading coefficient, look kind of like this. Some variation of that. If it has 3 distinct real roots, that means that this local maximum has to be above the x-axis, and this local minimum has to be below the x-axis. All right? Well, how can we know where local maxes and local mins are? That's where calculus comes in. So we're going to take our derivative. That's going to be 3x squared minus 6x. The k goes away. And we're going to factor this. That becomes 3x times x minus 2. So that tells us, remember, local maxes and local mins are when the derivative equals 0. So when we set this equal to 0, we know that we have to have critical points when x is 0 and 2. All right? Now, we could go further and check to make sure that the one at 0 is a maximum, the one at 2 is a minimum. In this case, I would recommend against it. Them being separate keeps it from being an inflection point, 1. And this positive leading coefficient tells you which one is the max and which one is min. More importantly, it doesn't actually matter which one's the max, which one's the min for the calculation we're going to have to do. So from this, we know that one has to be greater than 0, one has to be less than 0. So let's plug in our x's to this function and see what we get. When x equals 0, y is 0 cubed minus 3 times 0 squared plus k, which is just k. So what that tells us is that k, of course, has to be greater than 0. From this one, we can say when x equals 2, y is going to equal 2 cubed minus 3 times 2 squared plus k, which is equal to 8 minus 12 plus k, which is equal to k minus 4. So that, which is obviously lower than this, makes us comfortable with saying k has to be greater than 0. This has to be less than 0, which means that k has to be less than 4. So these split are our range. We can then gather these up and say that k has to be between 0 and 4. And then this last one, what is the limit as x goes to 0 of x cosecant x? This should inspire a little bit of panic when you look at it first, but we see a cosecant. Whenever you see one of the more complicated trig functions like secant, cosecant, tangent, cotangent, and it's in a situation that you're not familiar with, go back to the definition in terms of sine and cosine. Cosecant is 1 over sine. So this is the same as the limit as x goes to 0 of x times 1 over sine x, which we can clean up a little bit as the limit as x goes to 0 of x over sine x. Now at this point, if you don't remember this limit, that's about as far as you can go with the tools we have right now. There's one tool that you will get to second semester that will allow us to go further on this, but right now you just need to remember a particular limit, that the limit as x goes to 0 of sine x over x equals 1. Which, of course, when we flip this, that means that the limit as x goes to 0 of x over sine x, the limit we have, is also equal to 1. So this all just becomes 1. Like I said, if you happen to forget that, then this is as far as you can go, and I'm sorry. There will be a tool coming later that you can use to go further if you forget that, but that's not for a while. I can't say for certain because I haven't planned out that far. But that is it for the first page. Thank you for stopping by.